A recurrent ANN is one which simply has connections which go backwards, from the outputs back towards the inputs. Or, to put it in a different way, it has feedback. In other words, it's the opposite of the nets that we studied so far, which are called feed-forward networks. You may know that systems with feedback can display instability. Their outputs can increase to infinity, or they can produce oscillatory or even chaotic behavior. These are characteristics which feed-forward systems don't have. Such behavior can be undesirable in a system and make it unpredictable or cause unexpected results. It could, for example, lock up the outputs by making them tend towards infinite values, and this could crash the network. So given this, why would we be interested in adding feedback to our networks? Well, the answer is that such connections also add new capabilities to the network, and in particular they add a memory to it. We'll see exactly how this is produced in more detail in the next few videos. If you are familiar with digital electronics, you might notice similarities between feed-forward ANNs and combinational logic, and recurrent ANNs and sequential logic. One very important contribution to recurrent networks was made by the physicist John Hopfield in 1982, when he published an important paper on recurrent networks, and we'll look at his network in the next video as an example of a recurrent ANN. In a more general sense, adding a possibility of feedback into a neural network makes its structure more general, and in the extreme case, any neuron may be connected to any other one in an unlayered topology. This produces a general neural network.